naming the hydrates. We're going to name them the same way. This, looking here, sulfate's a -2. So because copper is a mom, we know it's a multiple oxidation metal is going to have more than one kind of charge. We need to figure out its charge. And if it's a 1-to-1 relationship there, what does the copper's charge need to be? This needs to be a +2. So when we name this one should be copper to sulfate. Now for the extra added part, because that part we already know how to do. We know how to name ionic compounds. The second part though is that we have this dot with the 5 waters next to it, indicating that it contains water in it and it is a hydrate. Okay? So we're going to use prefixes. Does anybody remember the prefix for 5? Penta. Good. So we're going to use the penta here to represent the 5. Okay? And all we need to do is add hydrate. So the full name is going to be copper 2 sulfate pentahydrate. So you put a prefix for the 5 and then you add hydrate to represent the H2Os. And that's how you would name the hydrate molecules. So I'd like you to do 1 through 4 over here. Spend some time practicing real quick. You may use your polyatomic ion sheet, use your periodic table to help you review how to do the ionic compound part. And then you just tack on the prefix with the word hydrate to represent the little part that comes from the water. Okay? So, give you about 5 minutes and we'll come back. Okay, so let's take a look up here. All right, forgot to fill out the top part. A compound that has a specific number of water molecules bound to each formula unit is called a hydrate. That's what it's called. It's called a hydrate. It's got water in it, like hydrated, has hydration. All right. Now here, let's go through some of these. First one, we have FePO4. Is that a mom? Yes, it's a mom. Iron's a mom. So how do we figure out its charge? Phosphate is a -3, so the iron must be a +3. So this is iron 3 phosphate. That's the first part. Now let's tack on the hydrate part. It says 4H2O. So what is the prefix for 4? Tetra. And the word hydrate, meaning waters. So, iron 3 phosphate tetrahydrate. What about the next one? Calcium. Is calcium a mom? No. What group is calcium in? It's in group 2, the alkaline earth metals. What charge do they always go to? +2. Very good. So, calcium what? Calcium chloride. Now for the hydrate part. 2 means what? Dihydrate. Good. Next one. Magnesium. Is magnesium a mom? No. Magnesium is also an alkaline earth metal. So it's going to +2. We don't need to write a Roman numeral there. So magnesium what? Sulfate. And the 7 gives us a what? A heptahydrate. Good. 7 means hepta on the prefix. Heptahydrate. Okay. Last but not least, down here we have Na. That would be sodium. So, is sodium a mom? Sodium's in which group? 1, alkali metals. And alkali metals always go to what charge? +1. So, we don't need a Roman numeral there. And what is C2H3O2? That is acetate. Very good. Acetate was one of the polyatomics you need to have memorized. Acetate. Now for the hydrate part, we have a 3 here. 3's prefix is trihydrate. Very good. Now, continuing on with our next section, just calculating the molar mass. The molar mass is not difficult to do. You do the molar mass of the beginning part just like you would normally do. So we would do Ca equals 40.08. We would do chloride, or the chlorines are 2 times 35.45. That is 70.90. And then we need to add in the mass of the waters. So if you look over here, you see that they tell you that water is 1802. You can keep using that amount each time. Why is it 1802? Because O is going to be 1 times 16, and the H's are going to be 2 times 1.01. So 16 plus 2.02 gives us 18.02 grams per mole for the waters. So every time you don't need to recalculate the mass of the waters because you know it's going to be 18.02. All you need to do is add in a line here. So for the water, it's going to be 2 times our 18.02. That gives us 36.02. 04, excuse me, 04. Right, 3604. Now all you have to do is take your calcium amount, your chlorines amount, and your water amounts and add them up. What do we get? What's that total? What's that total? Did you get 147.02? Anybody agree with that? Since it's a molar mass, it's grams per mole. So now what I'd like you to do is I'd like you to do the magnesium sulfate heptahydrate there down below. Solve that one. Find the molar mass, and we'll then move on to the percentage of water. Okay, so check this out. Did you get that answer? Did they all add up that way? Okay. 246.51. Now I'm going to use this example in the next section so that you can practice a little bit more. So in the next section on the next page, you're going to be doing the percent of water in the compound. So if you look up here, the formula is up here. You're going to find the mass of your water. You're going to divide it by the total mass of the entire hydrate. That's what you're going to do. Mass of the water divided by the total mass times 100 will give you your percent of water. Okay? Now, example listed here, 90 grams of water in copper 2 sulfate pentahydrate divided by the entire mass, which happens to be 249.6 grams times 100 gave you 36.1% water. So go to the tenths for your percentages. I'm going to skip down and do number 2 now, because we had already figured out the mass of the water was 126.14 on the previous problem on the previous page. We also figured out the total mass was what? Is it 246.51? Is that the total mass, right? So you know the mass of the water, you divide it by the entire mass times 100, and you'll get your percent, okay? Now for the other ones on here, though, you have to actually go calculate them because they weren't on the previous page, okay? So this ends up being 51.2% water, okay? So I would like you to try one of the other ones, see how you do, adding it up. Now it's always the percentage of the mass of the water divided by the entire mass of the entire compound times 100 will give you its percent. So check your number 1, how you did there. Did you get 63.0%? Check your numbers, see how you rounded your numbers. Everything needs to go to the hundredths for the masses.
I have no idea.
And then when you get 62.965, the 6 rounds up to 9 to a 0, which rounds up the 2 to a 3. That's how that works. Okay?
Is there anything else we're doing with Hydrate?
All right, on this third problem, just to reiterate, when you have parentheses, this outside 2 is going to distribute to both of the things inside. So you have barium, which is 1 times 137.3. But your oxygens are going to be 2 times 16. Your hydrogens are going to be 2 times your 1.01. Then you add in your waters at the bottom, which are 8 times 18.02. So that's how you would calculate that one to get your total mass. So continue on. When you're doing that, don't forget to distribute the outer 2 there. This 2, subscript 2, goes for both things inside the parentheses. One other quick thing, too, we forgot to do. It does say here that we need to name each of the following as well. So this one would be sodium carbonate, because we have carbonate here, we have sodium. We know sodium's not a mom, but it has 10 waters, so 10's prefix is what? So this would be deca hydrate. So don't forget to name it as well. This one we've already named on the front, but we'll go ahead and do it again. This is magnesium sulfate heptahydrate. Anybody like to name number 3 real quick? Barium what? What's OH? What's OH? Hydroxide. Good. That's one of those polyatomics you need to know. Barium hydroxide. Now, what's the 8 going to give us in terms of our prefix? So that would be octahydrate. Good. So don't forget to name them. Now we're moving on to the next page. And here, they give you a new vocab word at the top. You might want to highlight it. The word anhydrate. Anhydrate is the substance that remains once the water is removed. So like in the lab we're going to do next class, you are going to take the crystals, you're going to heat them up. Before you heat them, it's the hydrate because the water's in there. But once you heat them up, the water does what? Evaporates out. Very good. So what's left in there, the crystals that are left behind with no water in them, are called anhydrates. Okay? So it's like the opposite of having water. Okay? And we're going to do this in the lab next time. So there's a series of steps here. So if you follow the steps, you should be able to do these problems no problem at all. So in the lab too, we're going to take the mass of the overall hydrate. Then we're going to heat it, and we're going to get the water out of the hydrate. So that's step 1 and 2. Okay? Now, you're going to begin these problems with step 3, because you're not actually going to heat them. It's going to tell you it's been heated. You're going to take the mass of the hydrate, which is the total mass, minus the mass of the anhydrate to get the mass of the water. Or, if they give you the mass of the water instead of the anhydrate, you can take the mass of the hydrate and subtract the mass of the water, and that will give you the mass of the anhydrate. So either way it works, because they should add up together to give you the total mass. Once we figure out who's who, then we can move on to step 4. Okay? So I'm going to work step 3 real quick, and then we'll come back and look at step 4. So we're going to do number 1 together. There is also an example right here that you can follow if you'd like to. But here in problem 1, it says a hydrate of magnesium sulfate has a mass of 13.52 grams. So this says hydrate here, so that means that's the entire thing. So I have 13.52 grams of the hydrate, which is the total mass. Now the sample is heated until no water remains. The anhydrate mass is 6.60 grams. So if I put the 6.60 grams here and subtract that, which is the anhydrate, I do that subtraction and I get 6.92 grams, and guess what that is? That will be the water's mass. Because the anhydrate and the water should add up to the total, which is the hydrate's mass. Okay, so if we know those three numbers, we can continue on. Okay, and the next step up here, after we've done that, we figured out the water's mass. We need that part right there. We go back up to our steps. Step 4 tells me I need to convert masses of water to moles, and I'm going to convert the mass of the hydrate to moles as well. So I'm going to use the molar masses to convert everything over to moles. So let's go ahead and do the water first, because we know its mass. It's easy. What's water's molar mass? What's the water's molar mass going to be? You've used it a few times now, so 18.02. That one's easy to put in there. And you're going to calculate the moles of the water. So what do we get for the moles of the water here? Taking the mass of the water, okay, here, and we're going to convert it to moles, right there, using a T-chart. So we end up with 0.384 moles of water. Okay, so we know that value. The next thing that we need to do is we need to convert the mass of the anhydrate, this guy, the 6.60. We need to convert that to moles too. So I need to know the molar mass of magnesium sulfate. We can calculate that real quick. Magnesium is 24.31. Sulfur is 32.06. And there's 4 oxygens. So if we multiply 16 by 4, that's going to give me 64.00 for the oxygen. So if I add all that up, I get my molar mass of the magnesium sulfate. Which is 120.37 grams. So I'm going to stick that 120.37 grams down here and put the 1 mole on the top. And now I'm going to figure out my moles of the magnesium sulfate crystals without the water. What you will notice about this number too is, guess what? It is a lot smaller than the moles of the water. And you should always have smaller moles of the anhydrate to the water to calculate the number of waters you need to add in there. Okay? So this is the MgSO4 moles. Okay? So we first subtracted to find each mass from the total. Then we convert each to moles using their molar mass. That's the first couple steps there. Okay? Now step 5 involves using the moles, kind of like we did before with empirical and molecular formulas. You're going to take the larger one divided by the smaller one here. So it's always going to be the moles of the water being divided by the moles of the anhydrate. Okay? So let's do that. The moles of the water, 0.384 divided by the moles of the anhydrate. Now we're going to get a factor number. What's that number? And what do you get? Anyone? It is a 7. Good. So what does that mean? That means when I'm writing the formula, it's going to be MgSO4 with the dot, and the 7 goes in front of the waters. That's what we're finding there. That 7 goes here in front of the waters. Okay? So that is the formula that we needed to find, but we also need to write down the name. Let me correct that 4 real quick. SO4. There we go. So to write out the name, since I've run out of space, I'm going to do it over here. This is magnesium sulfate heptahydrate. Okay? Magnesium sulfate heptahydrate. So it seems like a lot of work just to get one little number to put in front of the waters. That's the way it goes. And I'm going to work one more for you on the back where they kind of reverse the numbers around. But if you just pay attention to what the numbers are telling you, you can figure it out. So yeah, let's look at the next one on the back. Not number 2, number 3. Okay, so number 3 here, it tells you when 5 grams of FeCl3, and then it gives us an X water. We don't know what this number is. That's what we're trying to find, that X, that value in front of the water. We have 5 grams, and then it tells us 2 grams of water are driven off. Okay? So what's my total mass of the hydrate here? Which one's the total mass of the hydrate? 5 grams. So we have 5 grams. That gives us the hydrate. Now, it said 2 grams of water are driven off. So this is now the water here. So if we subtract the 2, what are we going to get the mass of? The anhydrate. Very good. So we get 3.00 grams, and this is the anhydrate, which happens to be FeCl3, by the way. Okay? So that's the first step. What's the second step? What do we need to change our water and our anhydrate to? We have grams. What do we need to change those both to? Moles. We got to change it to moles. I'm going to start with the water because it's easy, because we know it's molar mass. What's water's molar mass? 18.02 equals 1 mole. So this is going to give us the moles of the water. So this is 0.111 moles of water. Not the water. Now I'm going to do the other one to find the the moles of the FeCl3. So 3 grams of that. 20 grams equals 1 mole. So now I need to do the iron, 55.85. You look over here on your periodic table. The chlorines, there's 3 of them, times 35.45, which is also off the periodic table. What's that value? This ends up being 106.35. We add these 2 together. The 55.85 and the 106, add those together, and we get our molar mass. And that would be 162.20 grams. So now I can put that value up here, 162.20 grams. So let's get those moles. How many moles of the iron FeCl3 are we going to have here? And yes, we're going to notice this number is smaller than the water mole amount. This ends up being, oops, I'm missing a 0, excuse me, hold on. It's 0.0185 moles FeCl3, right? Did you get that? And then our last but not least step here is to take our moles of water divided by the moles of the anhydrate. So 0.111 divided by 0.0185. And we're going to get that X number in front of the water. What does that come out to be? Anyone? It is a 6. Good. So if I write the formula now, it's going to be FeCl3 with the dot 6 waters. So we found that number 6 here, right here, that number, that's what we found. Now what's this guy's name? It is a hexahydrate, good, but it's iron what? What's chloride's charge? It's a -1, but there's 3 of them, so this guy has to be a +3. That's right, because remember the charges have to add it to 0. So -1, there's three of them, so this side is -3. So the iron has to be +3, so this is iron 3, chloride, hexa, you were right about the hexahydrate. Good. Okay, so that's how you have 3 more of these to go. Still have some class time, so whatever's not finished needs to be finished for homework for next class. And you can need to be working on your study guide. Don't forget study guide, because next class is the hydrate lab. The following class will be the test class.